Okay, Algebra 2, now we're going to do a section where we're going to see whether things are arithmetic, geometric, or neither. Okay, these are sequences. We're going to start with a sequence. This is the equation for an arithmetic sequence. This is an equation for a geometric sequence. It says on here, you can color them in purple, light green, and uncolored if you want. You can do that in the end. But let's go ahead and look at this. Number one, how do you decide if you want to check first to see if it's arithmetic or if you want to check whether it's geometric? Remember that arithmetic, you are adding or subtracting something each time. And for geometric, you are multiplying or dividing by something each time. So looking at number one, the fact that it goes back and forth between positive and negative tells you right off the bat that it can't be arithmetic. So it's got to either be geometric or neither. So let's check. To check for geometric, we would check to see if there's an R. And so we'll take the second term, divide it by the first term, we get -5. Then we take the third term, divide it by that, we get -5. And doing this, we get -5. So this is geometric, and R equals -5. And to write our rule, we would say, we're going to use this. We say AN equals A1 times R 3n minus 1. And that is it. Okay, number 2. We've got 15, 2 and 3, 5, 5/3, 5/9. All right. Just in your head, you can tell that you are not going to, it's not going to have a common difference, because the difference between these is 10, and obviously the difference between those is not 10. So it can't be arithmetic. So let's check to see if it's geometric. So we'll take 5 over 15, and that equals 1/3. Take 5/3 over 5, which is 1/3. And if we take 5/9 over 5/3, that's 5/9. That equals 1/3. So again, it's geometric, and R is 1/3. And to write our rule, we're going to do A1 times R 3n. Number 3, let's see A1, -2, 3, -4. All right, well, it's going back and forth between positive and negative, so it can't be arithmetic. So we'll check to see if it's geometric. We'll take -2 divided by 1, that is -2. 3 divided by -2 equals -3/2. It is not geometric, and it's not arithmetic, so it's number 4. We've got -18, -11, -4, 3, dot, dot. You can check. You can pretty much tell that it's not geometric. You can see it in your head. -11 over -2 is not the same as -11. So let's check to see if it's arithmetic. So we're going to take -11 minus -18. this is arithmetic. And arithmetic has a G, arithmetic has an S. G is 7. We're adding 7 each time. So to find our rule, we're going to use this. I'm going to say n equals 3 times n minus 1 plus a1. Don't leave it like this. Simplify it. Give it the 7, and then write it as 7n minus 25. That is how I like to have it. Okay, 5. We've got 1, 8, 27, 4. Going up pretty quickly. You can tell that it's not arithmetic because the difference between this is 7 and the difference between this is a lot more than 7. So let's check the geometric. We've got 8 over 1 equals 8. 27 over 8 does not equal 8. So this is number 6. We've got 9/4, 5 halves, 11/4, 3. Okay, let's see if we have 5 halves minus 9/4. That is, we would have to get a common denominator, so we could write that as 10/4 minus 9/4, and that is 1/4. So then if we do 11/4 minus 5 halves is 11/4 minus 10/4, which is 1/4. And if we do 3 minus 11/4, that is 12/4 minus 11/4, which is 1/4. So this is arithmetic. And D equals a fourth. We're adding a fourth each time. So to find our rule, we're going to say D times n minus 1 plus a1. And we're not going to leave it like that. We're going to distribute the 1/4. And we're going to say an equals 1/4 n plus, say, 9/4 minus 1/4 is 8/4. And 8/4 is 2. So there is our rule right there for number 6. Okay, number 7. We have -3, -27, -243, -2187. That's a negative. All right, this is going up very quickly, so most likely it's geometric if it's either one. So we're going to say -27 over -3 equals 9. -243 over -27 is 9. And -2187 over -243 is 9. So this is geometric, and our R is 9. So our rule is A1 times R to the n minus 1. Okay, that's why I said that geometric is easier sometimes. Let's look at number 8. -5, -17 halves, -12, -31 halves. Which one do you think it might be? I think it might be arithmetic. So I'm going to say -17 halves minus -5. And I'm going to write -5 as 10 halves. And that equals -7 halves. And if I do -12 minus -17/2 and write the -12 as -24/2 plus 17/2, I get -7/2. And if you did the third one, you would get the same thing. This is arithmetic, and D equals -7/2. So to find our rule, we say D times n minus 1 plus A1. You don't leave it like that. You go ahead and distribute that. And then what is 7/2 minus 5? Well, we can write that as this, and that equals -3/2. So our rule would be this for number 8. And the last one here, number 9, we've got 100, 40, 16, 32/5. Right away, when we have whole numbers and they go down to fractions like that, you know that it must be geometric if it's either one. So let's try that. If we do 40 over 100, that equals 4 over 10, which equals 2/5. And if we do 16 over 40, we say 8 goes into there 2, 8 goes into there 5, 2/5. And if you did the last one, you would also get 2/5. So this is geometric, and R is 2/5. And our rule is A1 times R to the n minus 1. And we're done. Okay, now the next part is series review. Remember, when we're looking for a series, we're adding up things. We're getting a sum. Your answer is going to be a number. And if we are using an arithmetic series, the equation that we used was n times A1 plus AN over 2. And for geometric, we used A1 times 1 minus R to the n over 1 minus R. These are for finite. These are for series that end, that have an ending. Okay, so now you have to decide if it's arithmetic or geometric and then find the sum. So let's look at number 10. Looking at number 10, do you think that might be arithmetic or geometric? I think it's probably arithmetic because it's pretty even there. So if we did -1 minus 3, we get -4. -5 minus -1, we get -4. And -9 minus -5, we get -4. So this is arithmetic. And D is -4. Do we need D? We do not. We need, oh, what did it ask us? It asked us to find S26. So to find S26, we need A1, which is 3, but we need A26. So we need that D to find A26, which is -4 times 26 minus 1 plus 3. So you would do this and you should get -97. So we get 3 plus -97 over 2, and you get -1222 for your answer for number 10. Okay, remember a series is a number. Your answer is a number. Number 11. If you look at it, you're going to be able to start looking at it and deciding if you think it is geometric or arithmetic. This is geometric because the difference between these first two is 30 and the difference between the next two is 15. So this is geometric, and R is negative 30 over negative 60, which is 1/2. So to find S14, we take A1 times 1 minus R to the 14th power over 1 minus R, and you're going to get negative 245,745 over 2048, which is approximately negative 119.99. Okay, number 12. This one's easy. When it's in summation notation, you can easily tell whether it is geometric or arithmetic by the form that it has. So what does this one look like? This is geometric. And there's R, there's A1, and there's N. So we'll say S9 equals A1 times 1 minus R to the 9th over 1 minus R. And you'll get negative 1533. Number 13, again, we got X equals 4 to 39 of 5X plus 2. Okay, well this one is arithmetic, because you can tell just our A1 is when X equals 4. So it's going to be 5 times 4 plus 2, which is 22. And our last term is A39. Well, our N, let's do our N first. Our N is 39 minus 4 plus 1, which is 36. So our last term, A36, is when N equals 39. So we do 5 times 39 plus 2, and that's 197. So our sum is N times the first term plus the last term over 2, which is 3942. And number 14, we've got N equals 4 to 22 of 1 minus 1/3 N. Okay, this is arithmetic. You can tell just the way it's written. And our N is 22 minus 4 plus 1, which is 19. And our first term is when N equals 4. So it's 1 minus 4/3, which is negative 1/3. And our last term is when N equals 22. So that is this, which is negative 19/3. So our whole sum now is N times our first term plus our last term divided by 2. And when you do all of this, you should get 190 over 6. Well, I'm going to actually do this. Make sure I'm doing it right. Okay, so this is 1920. This is negative 20/3 over 2. So that's negative 20/3 times 1/2. 2 goes in there 1, 2 goes in there 10. So this is negative 190 over 3. I think that's right. I think that's the correct answer. All right, number 15. We got the sum of m goes from 2 to 10 of negative 16 times 1/2 to the m minus 1. All right, this right away you can tell is geometric from the way it looks. And our n is 10 minus 2 plus 1, which is 9. And our first term is when m equals 2. So that is negative 16 times 1/2, which is negative 8. So our sum is negative 8 times 1 minus 1/2, so that's our r, to the 9th power over 1 minus 1/2. And that gives you negative 511 over 32. And our last two here are infinite. And remember that you can only find the sum of an infinite geometric sequence when it is convergent. This one, number 16, is convergent because r is negative 3/4 and the absolute value of r is less than 1. So we're going to use this equation and we're going to say that the first term is negative 5 over 1 minus negative 3/4. And that is negative 5 over 7/4, which is negative 5 times 4 over 7, which is negative 20 over 7. And that's the answer. And for 17, we've got n equals 4 to infinity of 1/3 times 6 to the n minus 1. And this is geometric, but r is 6, and the absolute value of r is greater than 1, so it's divergent, and we can't find the answer for that. So it just goes to infinity. All right, now we got a couple applications, 3 applications to do here. You've got to read the problem and decide if it's geometric or arithmetic, and then decide if you're looking for a term, like an A, or if you're looking for a sum, and then for an S. So in number 18, Ian is playing a video game. The number of points he's earned after every hour shown below. Determine whether this represents an arithmetic or geometric sequence. Then find the approximate number of points earned after 9 hours. Round your answer to the nearest 100. All right, so do you think it's arithmetic or geometric? Well, let's check. Let's do 480 minus 384, and you get 96. And if we do 600 minus 480, we get 120. So it is not arithmetic. So let's check to see if it's geometric. If we take 480 over 384, we get 1.25. And if we take 600 over 480, we get 1.25. So this is geometric. So that's the first thing. It said decide if it's geometric or arithmetic, and then find the approximate number of points earned after 9 hours. So that means we don't want to add them all up. We don't want a total number of points. We just want to find a 9. So since it is geometric, we're going to use this equation, and we're going to say A9 equals the first term, which is 384, times r, which is 1.25, to the 9 minus 1. So you're going to go ahead and do that on your calculator, and you should get 2288.8, whoops, 0.82. Okay, it says round the answer to your nearest hundredth. That's 2 places. So this is approximately how many points he's earned after 9 hours. Right, number 19, Michaela is building a pyramid of paper cups. The bottom row has 61, while the top row has only 1. If there are 16 total rows and the number of cups in each row represents an arithmetic sequence, find the total number of cups. So this one tells you that it's arithmetic, and it tells you that a 1 has 61, and a n has 1, and n is 16. So I guess we could write this as A16 has 1. So we want to find the total number of cups. So that's telling us that we're looking for a sum. And since it's arithmetic, we're going to use this. So in this case, that would be 16 times the first plus the last over 2. And this gives you 496 cups for the total amount. And the last one, the amount of interest, usually right away when you hear interest, that should tell you that it's geometric. The Ben earned on his savings account for the past 3 years since opening the account is shown in the table. Determine whether it represents arithmetic or geometric, and then find the total amount of interest that Ben will earn after 20 years. All right, well, I told you that you probably interest is geometric, so let's check it. 79.20 over 72 equals 1.1. And if you do 87.12 over 79.20, you get 1.1. So yes, this is geometric. And R equals 1.1. It says, find the total amount of interest that you will earn after 20 years. So that tells you it is a sum that you want. And since it's geometric, we're going to use this. And we're going to say A1 is 72, R is 1.1, N is 20, and this should give you 4,123.80 cents. And that is the end of this chapter.